Alrighty, it's been a hot minute since we've done this, so let's see. So class.
Yes.
Okay, good, awesome, amazing. All right, derivatives of inverse trigonometric functions. Now, I told you guys in beforehand, kind of got to try and memorize these things. You got it, because it's really not that easy to go through and actually figure them out. But we have to use it using inverse functions. So, for this one right here, it says, find the derivative of an inverse function. The theorem of an inverse function, if y is equal to f of x and x is equal to g of y, be inverse. Suppose f is differentiable on an open interval containing the initial x and y, then f of x is equal to oh wait, here it is. Where did I lose? Okay, containing initial x and y is equal to f of x of your initial. If f prime of x of naught is not equal to 0, then g is differentiable at the initial y of f of x. And so, rewriting it, instead of being a d dx, it is d dy of g of y when y is equal to my initial value. Then g prime, that's the inverse, okay, the inverse of g is equal to, so right here, this one's equal to 1 over the derivative of x. The derivative of x. So remember, g has to do with my y values. The function g has to do with the y values. And then the inverse of it is 1 over the derivative of f at the x value. So this is one of those ones that is actually gets super complicated. And it is one of those things that I'm saying, like I said, you gotta remember these things. These are not things that, like, to find the derivative of tangent, you can't just do the quotient rule off of this. Okay, it's not that easy. So, in words, derivative of a function is equal to the reciprocal of the derivative of its inverse function. Hopefully those keywords actually help. So, if your function's this and has an inverse function g, find g prime of 2. Okay, so let's start with f prime, right? Okay, let's do an f prime. So f prime of x is equal to 5 at 4 plus 1, right? And what do we say our 2 is from? Our 2 is from what? Okay, the 2 represents a what? It's a y value. The 2 represents a y value. That's important. That's your y value. So could I go through and try and figure out what it is? Can we do it? Yes, we can. All right, so I could say that 2 is equal to x to the 5th plus x. 2 is equal to x quantity, x to the 4th plus 1. Now, we solve for x. So here, x is equal to 2. Now, I'm going to try and do this one right here. So 2 is equal to x to the 4th plus 1. Right? Okay, so what do we do with this right here? Because I could set each one equal to, and then subtract 1. So 4th root of 1 is equal to x. What is the 4th root of 1? What? Can I test to see if that works? Yeah, let's test to see if it works. So we could say x equals 2. So right here. So 2 does that work? Say no. Why doesn't that work?
What happened to the x? What happened to the x right before the x? X before, yeah.
This was a 5,
Yeah.
and now it became a 4.
Yeah.
That was a 1,
Yeah.
right? And it's because I factored that out.
Yeah, but what happened to the x on the next one?
Okay, so that is key right there. So this is where the problem happens, right in here. It's not the same. There's a rule that makes this true, but I didn't apply that rule. And I say it every single time that we go through and do this. For this to work out, I have to use what rule? It's my favorite number. Zero. Zero product rule. Anything times 0 is 0. So I can't really do this the same way as I was, right? I can't just throw it in there like that because you have to use 0 product rule. So if I'm using 0 product rule, I am this is come on. So my problem is right before this. Zero products rule says I have to do what? Set it equals 0, right? Okay, so subtract 2. So 0 equals x to the 5th plus x minus 2. And I already know this is already going to have one solution. Anyone know what the one solution is? 1. It's going to be 1. That's it. That's the only thing that's actually going to work for this one. It's going to fit. It's going to be 1. So if x equals 1, so 1 to the 5th is 1, plus 1 is 2, minus 2? Yeah, there we go. So that's the only thing that's actually going to fit in this one. So all I have is x equals positive 1. So I have a value, and that's important. So now I started off, I only had my y. So there's x. So that was 1, comma, 2 is my x and y now. So on that previous slide, to find the derivative of this, I would say that g prime of 2 is equal to, read it directly off the other slide, 1 over f of initial x, right? Thank you very much. So my initial x in this case was 1. Thank you. Now, does that make sense? So we use that format right there. So I had the hardest thing was actually finding my x given my y. That was the hardest thing out of all this. I did my derivative here. So now let's go ahead and it's going to be g of g prime of 2 is equal to 1 over, let's see what we get here. So as we plug in 1, we're going to get 6. Yes? So right here, so 1 to the 4th is 1 times 5 plus 1 is 6. Do you have the 3, 3?
Oh, yeah, my backpack, I left it at work.
How dare you? You need another one?
It's what anyways. I'll take it with mine.
Okay. Was that one just left there?
Yeah.
Oh.
I have mine.
Okay. All right. Are we good? Questions, concerns, complaints? Go ahead, Blake.
So f prime x, is that supposed to equal the reciprocal of g prime?
Yes. To get the derivative of g, where g is the inverse, right? You have to put 1 over f prime of x, where g is the y value. This is the y value at that current point that I'm looking at. Okay? Function x cubed plus 2x minus 4 is 1 to 1 and has an inverse function g. So it has an inverse function already. Find the equation of the tangent line to the graph of g at the point 8, 2 on g. So I need to use g. So that means that I am looking for g prime of 2 should be equal to, say it again,
F 1 over F.
1 over f prime of 8. And we're doing an equation on the tangent line. Uh, 8, 2 on G. Yep. This wording is getting me. I think this is the one that's actually backwards. Because this is already on G. There it is. This one's on G. So for this one right here, my initial and is going to be 2 comma 8.
Why is it blue? Is it
Me-
inverse?
Yes, this one right here says find the equation of the tangent line of the graph of G at the point, and this is on G. So that means that everything in G is flipped from what we originally had.
So it's giving us the information of the flip, and we have to unflip it to find the OG.
Yes, and so I need to change these then. So did you guys hear what I said there, or no? Or did you at least understand, kind of? Okay. Because the words right here says at the point 8, 2 on G means 8, 2 is the x value on G. Right? So that's the x value on G. So 8 is the x, 2 is the y. That's on G. So this is the inverse of the function that I originally had. So this already got moved from my initial point should be 2, 8. And it's just this little word. And I barely remember just right now, because when I did this last year, I'm like, man, why is it different? And so yeah.
So we gotta work backwards.
From that one. Are you agreed, Tree?
Did we have the parabolic lesson?
3, 3? No. I skipped hyperbolic.
Hyperbolic function. Did we do that?
No. Don't do hyperbolic.
Oh, okay. Sorry, I saw it.
Okay, go ahead.
So to do the inverse would be g prime of 8 over 1 of f prime of 2.
Very good, yes. And that's what the change needed to be. Because if we're looking at g as a function now, remember, g of my value was always g of the y. But if it's this on here, it's g of 8. Does it mean the same thing over here now? So if I look at my original function, it would be g of 8, right? And if I look at my original function f, it would be f of 2. Should give me that. So the trickiness is just that point right there, which I wanted to point out. And that's the reason why this one is kind of a pain in the butt. So just those words that says the point, it's on G. It's not on F, it's on G.
So then do we input, so we find the f prime, which would be 3x squared plus 2.
3x squared plus 2 is my f prime of x, right?
Yeah, and then do we do f prime of 2 or do we use the
2.
product rule?
Yeah, it's going to be up 2.
Okay. So that'd
Did you
be
make us do it anyways?
No.
We did do it for like a little bit.
No. It came up in pre-calculus. I don't do hyperbolic though. So you probably had it in pre-calculus. That's what you're remembering. Okay, so this is going to be, let me see, f prime of 2. So that's going to be 2 squared 4, 12, 14.
Yeah.
So g prime of 8 is equal to 1 over 1 4. Now, what does g prime represent? Do you guys recall? The derivative of the y, right? It's a derivative. What does derivative really give me? Slope, very good. Slope, slope, slope. That's what I needed. So when I said, hey, I need to have it on this, that means if it's on G, I'm plugging it in this right here into my point slope. So I have the slope right here. So it's going to be y minus 2 equals 1 over 14 times quantity of x minus 8.
Wait, how did you get that? Oh, because you're doing it in point slope.
Yeah.
Duh.
So what are you trying to find?
Equation of the tangent line on G.
What?
What do you mean?
We're working backwards to find f of x, right? Or to find f.
Okay, so it asks for the derivative of the inverse. So G is my inverse. So someone wasn't here when we talked about this in the first place, because they had to show up late. So if you were here on time, you would have noticed that we have a slide right here, and we have these right here. Those are your x's and your y's. So we're going to keep referencing this over and over again. So we have f right now, and we're trying to find g prime using that.
Why?
Yes, the y, given the y. They're inverse functions.
So you're trying to use the inverse function to find the
We're finding the derivative of an inverse function.
So you have the function, and you're trying to find the inverse or the
Derivative,
of the inverse function.
yes.
By using this instead of just like doing the inverse function and then.
Okay, so if you were going to do the inverse function, what would you do?
You would switch the x to the y, right?
Switch your x and y, right? So try, but not all the time are you able to actually isolate your x by itself to get it to x equals, right? Because you have problems in which that it's not a function. That's not going to work. So you can't do that. So we have this. So, make sense? Better? Okay. Those people actually showing up on time. Okay, so from this right here, I'm going to do, let me see, that's going to be y equals 1 over 14x minus, what's that, 4 over 7? Yeah, 4 over 7. And that's going to be plus 7 over 7. So y equals 1 over 14 x plus 3 over 7.
Is it supposed to be 14 over 7?
Say what? Where are you at?
When you add the 2s, it's supposed to be 14 over 7.
Oh, you're see? Good job. See? That is good job right there. That's like candy worthy right there. So that makes 10 over 7? 10 over 7. Good job. I have to restock. My Halloween wasn't very good. Unless anyone want to share their Halloween candy. No one ever shares their Halloween candy. That's their diabetes. Questions, concerns, complaints, conspiracy theories. Are we still good? Yeah, Blake.
Where'd you get 4 over 7?
What's negative 4 plus 14?
10 over, yes, 10.
We're combining these right here.
Oh, no. Where did you get negative 4 over 7? Like the first place?
Oh, okay. Distribute this. What's 8 over 14? Reduce it.
1/2.
No, that's 7 over 14. 8 over 14.
8 over 14.
So half of 8 is 4. Half of 14 is 7. So that's where the 4 over 7 came from. All right, we good so far?
When did you transfer the negative 2 over 7?
Right here. So here went to here. Because I have to add it, right? You're adding 2. You're adding 2, but over here I added 2, but it's 14 over 7. Other questions, concerns, complaints, conspiracy theories? Okay, let's keep going. So, derivative inverse trigonometric function. So this one's actually going to be one of the ones that you really need to try and, I think the ones that are hit on the most are sine, cosine, and tangent. That's it, sine, cosine, tangent. So when you see these inverses of these right here, that's not a power, that's an inverse. And so, like here, so derivative of inverse sine or arc sine, you could also see it as arc sine. X is going to give me this. So whatever your x value is, it's 1 over square root of 1 minus x squared. All right, this first one right here, what rule applies there? What rule applies on this first one?
When we do that U thing.
Yes, the U thing. Starts with C, has it.
Well, besides the chain rule, are you?
Yeah, it's chain rule. It's chain rule, yeah.
Well, it literally says that. Why would you ask them that?
No, you had it right, but the U thing is the chain.
Yeah.
So we're going to say that U is equal to U prime. so this is going to be y equals inverse sine of u.
And then y prime is
Y prime is equal to, what do we say sine was?
negative cosine.
No. This is the arc sine. This is the inverse sine, the one that was previous slide.
It's the one over.
1 over
Oh,
Right. 1 minus x squared
1 minus
x squared.
x squared. But what's my x on this one?
Oh,
U squared times u prime. And writing it down step by step is super important. Every single step. I do this for a reason. Keep everything organized.
so it becomes y prime is 1 over the square root of 1 minus 4x squared
Squared.
times x, or 8x.
I'm going to do it right. So, that was a prime right there. So y prime is equal to 1 over 1 minus, what's 4 squared? 16, right? And x squared?
16x.
x4, very good, times u prime, which is 8x. And so the only change I would do is put that 8x on front. And now that's what you had, or do you have 20? I saw like 24 or something in there. Yeah. How'd you get a 24? Oh, good. Yeah. No, it's whatever the u was. So like I said, write it down specifically with the u notation. I think you skipped that step, so that's why you kind of lost out on that. All right, next question. You guys ready for B? All right, let's see if you get started without me.
The u would be the sine.
Mm-hmm.
What's that about like proving that x of x over x has the x except for 0 is equal to 1?
Are you talking about the sums?
Like
As x approaches.
well, sine of x over x.
Oh yeah, that's a cool one.
Yeah.
So that's the limit on that one.
What's the one that we actually have to do proof for on the test?
That you do or don't?
Do like MBT, EBT.
Oh, mean value theorems. Oh, you just have to show what it is.
Well, what else besides those?
At this current moment in time, I can't like change gears. So
So with
give
the
me a
y-
second. I'll look at it for you. Okay.
So the y prime would be e raised to sine negative 1x times 1 over square root of
Are you
1.
trying to tell me the answer?
We'll like just get to the point of the derivative.
Oh, here. Oh, okay. So arc sine x. Right? So you're going to say that u is equal to arc sine.
Would you just multiply the
We don't have an x.
u by u prime? For the
Huh? Where's your x at? Your x is with this.
Yeah. But we don't have to get it past the point of the y prime. Like the other one.
Is that what I was currently working on?
the y prime, would that be e prime?
Yeah.
Okay, great.
So, and we said this was 1 minus x squared, so there's my u prime. So y equals e to the u, y prime is equal to e to the u times u prime. So y prime is equal to e to the,
Arc sine
yeah, arc sine,
times 1
1
over
square root of 1 minus x.
and then we get to shop for.
yeah, you can combine it and just put e to the arc sine like that.
Are we supposed to do the ln thing?
Nope. The derivative of e to the x is e to the x. ln is something else. That has to do with the log.
You're right.
Is that the part that you're confused with? Derivative of e to the x is e to the x. Okay. All right, tangent, arctangent. So no square roots. 1 over 1 plus x squared. The reason why I try to remember this as best I can because this is what pops up the most when we're dealing with integration. Integration is the undoing of a derivative. So if I start a problem with 1 over 1 plus x squared, and I have to work my way backwards to here, it would give me arctangent. So integration works from the right to the left, where derivative goes from the left to the right. So that's one that, like I said, I always remember because of that. So you have this one, this slide on speed dial. So let's look at this one. Arctangent 4x. What's my u?
Y is arctan u, y prime is 1 over 1 plus x squared times u.
U prime.
Wait, no,
Oh yeah, it's u squared. Sorry.
yeah.
And then y prime is equal to 1 over 1 plus 16 x squared times 4.
Y prime is 4 over 1 plus 16x squared.
Yep.
Where b, the u would be arctan of x.
Yep.
Is that a 2?
So this one goes back to my sine, right? So it's 1 over square root of 1 minus,
10, or tan of x.
not
squared.
yet, let's still take care of the u's.
Oh, u
U,
times
is it u squared or u, okay, u squared,
and then times
u prime. Notation is great, step by step, so you don't get lost in this. Every step is important. So, y prime is equal to 1 over square root of 1 minus u squared, which is parentheses 1 over 1 plus x squared times u prime. Oh wait, no. I put that in too soon. Sorry, yeah.
It's just arctan squared.
I was putting the wrong one in there.
U prime is the
Yeah.
inverse prime. X squared.
There we go. Alright. You guys feeling okay still? I know I've thrown a lot of stuff at you. I'm going to stop there though. We're going to pick this up tomorrow. I want you guys actually starting this assignment. Even though if you're already like, you know, not up to that point, I want you to try some of these inverse questions right now, please. So, other than that, like, share, and subscribe.